Alright, so we have introduced this term document inside the matrix already, right? In other words, so based on this matrix given one term, we will be able to access its appearance in all the documents by retrieving one row in the matrix out, right? So Anthony, we can retrieve the first row. For Brutus, we can retrieve the second row, and similar for the remaining ones, right? It will also be very similar given a document. If we want to check the appearance of the terms in it, we can also retrieve the columns in the matrix as well, right? However, normally when we're building this inverted index, in other words, we want to search for some documents given some token inputs. Normally we will retrieve the rows for each of the terms instead to help us do the queries, right? We'll show you with an example. So normally given one term, we can access or retrieve its incident vectors based on the previous matrix, right? And so we can have all the 0, 1 vector values for them. Each of these values denoting if this token or this word appear in the documents or not. So based on these vectors, we will be able to build not so interesting queries to answer many of the inputs. So for example, to answer the query, Brutus and Caesar and not California, right? In other words, the query we are doing here is to search for documents contains Brutus, Caesar, however it doesn't contain California, right? Then how can we do this query? So based on the matrix we showed in the previous page, we can retrieve all the vectors, all the rows for the word Brutus, Caesar, and California, right? We can take the rows, all the vectors for them, and then we can build a query according to what we have here. So based on these vectors, we can do a bitwise Boolean expression for them, right? Now here, if we can have access to the Brutus, Caesar, and California vectors, which can be denoted by 110100, right? It's for the Brutus, similar for the Caesar and California. The way we can do here actually is to do the AND between Brutus and Caesar, these two vectors, right? However, for California, we have this not here, right? In other words, given this California vector 010000, we have to do the complement first, right? Complement of the vector for California first, and then we can first AND them together, right? In other words, based on the query inputs, the way to answer this query actually is via the Boolean operations. So given the Brutus vectors, Caesar vectors, as well as California vectors, we do the Boolean operators according to the expression. We do the not first and then first AND them together. The result we can get actually is 100100. How to interpret this result? This one denotes its corresponding documents can meet our requirements. It contains Brutus, contains Caesar, but it doesn't contain California, right? And the document 1 corresponds to the Anthony and Cleopatra, right? It can meet our requirements and should be returned as a result. Also, for the fourth document, the Hamlet, it also contains the Brutus, contains Caesar, but doesn't contain California, right? In other words, this document Hamlet also should be returned as a result. So you see, the query process will be relatively very easy, also very fast, based on the Boolean models. We just get the vectors first, and then do the Boolean operators based on the vectors to get results, which can meet our requirements. And for the other documents corresponding to the 1 values, we will return them as the final results.